Welcome friends, in this video we are going to look at science paper 2 for the year 2013 and we have the first question. Chlorine has two isotopes. We have chlorine with a mass number of 35 and another one with a mass number of 37. Then question A, define the term isotope. So we'll say atoms of the same element. With the same atomic number but different number of neutrons. So the reason why we have two different mass numbers is because of having the different numbers of neutrons. And we are going to see that by the calculations that we have in question B. So under question B, set the number of neutrons in each of the following isotopes of chlorine. So we begin with chlorine with a mass number of 35. So what you do is you get the mass number, which is 35, you subtract the atomic number 17. So the first one has 18 neutrons. Then for the second one, it is 37 minus 17. So 37 minus 17 will give us 20. So we can now see and verify that what makes the two or more mass numbers to different from each other is because of the presence of the neutrons. So under the first one, we have 18 neutrons, while the second one has 20 neutrons. Then we move on to C1. So under C1, draw the atomic structure of an atom of chlorine. So our focus is just the atomic number. So begin by first giving the electron configuration, of which the first shell must occupy 2 electrons. Then if we subtract 17 minus 2, we have 15. Then the second shell will occupy 8 electrons. The outermost shell will occupy 7 electrons. So the atomic structure, you begin by, you write this chemical formula. Then from there, you write the first shell, 2 electrons. Then we'll have the second shell with 8 electrons. Then our outermost shell will have 7 valence electrons. So this is our atomic structure of chlorine atom. So we've done this answer. Then we move on to question Roman number 2. Give the formula of a chloride ion. So an ion is a charged atom. In our case, an ion is charged by gaining 1 electron. So since it gains 1 electron to become stable, we put a -1, which is just minus. Then for question D, explain why the relative atomic mass of chlorine on the periodic table is not a whole number. So if you look at the chlorine on the periodic table, you see that we have 35.5. So the reason why it's not a whole number, we'll say because chlorine exists in the isotopes forms, like the one that we've seen above here. We move on to question 2. The table below shows the properties of an alkali, an acid, and a salt solution. Then we have question, complete the table. The first column is solution, the second one approximate pH, then the ions present. So to finish Roman number 1 and 2, first we need to look at the ion present. So the ion present, we have sodium hydroxide, which is the sodium cation, and hydroxide anion. So this is a base, and whenever you are dealing with a group 1 metal, we are dealing with a strong base. So this can be 13 or 14. So since we are just giving approximation, these two can be answers, because for a strong base, we need at least 12, 13, 14. These are pH values for a strong base. Then the solution will be sodium hydroxide. So the sodium, this is our sodium from then we have this hydroxide. So this is what I've used in order to come up with the solution. Then we move on to have hydrochloric acid. So hydrochloric acid is a strong acid as well. So this one we can use 1 or 0. Then the ions present, we have hydrogen positive, then the chloride negative here. Then the sodium chloride, we have 7. Then the ions present, we have sodium plus, then the chloride minus. B, name the two solutions from the table which when mixed together form a solution of sodium chloride. So for us to have sodium chloride, we need to react sodium hydroxide with hydrochloric acid. So two solutions. The first one is sodium hydroxide and hydrochloric acid. So this reaction is a neutralization reaction, because we are looking at a strong base and a strong acid. So whenever we have such a reaction, the products will be neutral. Then we move on to question 3. Under question 3, we are just taught to define the relative molecular mass, which is the one we refer to as Mr. So how do we define the relative molecular mass? So we'll say this is the ratio of the average mass of one molecule or compound compared to 1/12 of the mass of an atom of carbon 12. Carbon 12. Now we move on to question B. Question B, we have potassium carbonate, which is a metal carbonate, react with dilute sulfuric acid to form potassium sulfate, carbon dioxide gas, and water. Construct a balanced chemical equation including state symbols for the reaction above. Now, if we look at potassium carbonate, potassium has a symbol of K, carbonate has a symbol of CO3. Then the valence for potassium is 1 since it is coming from group 1. Then here we have 2. So if we interchange, then we have the chemical formula potassium carbonate with a 2 here and a 3 here. This is solid plus what are we reacting with? So we are reacting with sulfuric acid. So the chemical formula is H2SO4 aqueous. Then we are given what will be produced. So what will be produced is potassium sulfate. So potassium is K, sulfate has a valence of 2, so we put a 2, then SO4 aqueous, plus what else is being produced? We have carbon dioxide, CO2, plus H2O. Then from there we are told to balance our chemical equation. So let's see if this equation is balanced or if we need to do some balancing. So our equation, if you look at this equation carefully, our equation is balanced. Check. From the reactant here, we have 2 atoms of potassium. On the product, we have 2 atoms of potassium. Then let's check for carbon. Carbon, there is 1. Also here, carbon, there is 1 atom. Then let's check for hydrogen. From the reactant side, we have 2. This one here. From the product, we have also 2 from water. Then we have 1 atom of sulfur. 1 atom of sulfur. Let's check for oxygen. So oxygen, we have 3 atoms of oxygen in potassium carbonate plus 4 atoms of oxygen in sulfuric acid, which is in total will give us 7. Now out of here, there is 4 from potassium sulfate plus 2 from carbon dioxide, giving us 6, plus 1 from water, 7. So this equation is balanced. So this is a balanced chemical equation. Now we move on to Roman number 2. Calculate the mass of potassium sulfate produced when 2.0 grams of potassium carbonate react with an excess of dilute sulfuric acid. So here we have been given one mass of we have been given the mass of one substance, and we want to use that mass to find the mass of potassium. So calculate the mass of potassium sulfate. So we want the mass of potassium sulfate. So let's look at the mass that we are given. 2.0 grams is for potassium carbonate. So say potassium carbonate. Then we want the mass of potassium sulfate. So the mass of potassium carbonate is given 2.0 grams. Then for potassium sulfate we don't have, so we just put X. Then what else are we supposed to do? We are going to find the relative molecular mass for potassium sulfate and relative formula mass for calcium carbonate. So here we need a periodic table. So let's do our calculation. So we'll say Mr. is equal to, from potassium carbonate there are two atoms of potassium, so potassium times 2, plus there is only 1 atom of carbon, so carbon times 1, plus oxygen multiplied by 3. So from the periodic table, potassium has a mass number of 39 multiplied by 2, 12 times 1, 16 multiplied by 3. So 39 times 2, I'm getting 78, plus 12, plus 16 times 3 is 48. So 78 plus 12 plus 48, I'm getting 138. So this relative formula mass is for potassium carbonate, so we are going to put it here where there is potassium carbonate. Then we need to also find the relative molecular formula mass for potassium sulfate. So we need to carry another calculation. So potassium times 2, sulfur there is only 1, so sulfur multiplied by 1, plus oxygen multiplied by 4. So Mr. is equal to potassium 39 times 2, sulfur is 32 multiplied by 1, oxygen is 16 times 4. 32 times 2 will give us 78, plus 31 plus 16 times 4 will give us 64. So we have 78 plus 31 plus 64. I'm getting 173. So is what we are going to put here. Then we cross multiply. So our task from now on is now to find the value of x. So 138 times x is 138, x is equal to 173 times 2. I'm getting 346. We divide by 138, 138. Then x is equal to, so I'm getting 2.50, which is 2.5 grams. So this is the mass of potassium sulfate. Okay, so this is how we can carry out a calculation like this. So for this one, to summarize, we are saying whenever a metal carbonate react with any acid, salt, carbon dioxide, and water must be produced. Then the question C, what is the identity test of the gas produced in the reaction above? Remember, the gas produced is carbon dioxide. So the identity, we just say it turns lime water milky. We move on to question 4. Water is an important raw material in the home and in industry. State 2 uses of water in industry. So 2 uses of water in industry. So there are so many uses that we can give. So like during formation of alcohol. Then the other one, to cool machines. So whenever we know that whenever a machine is operating, and because of the friction force, we might find that the machine is heated, the temperature is heated. So in order to reduce that temperature so that it works effectively, water must also be there. So there are so many uses of water, you can just give any of it. Then B, outline the 2 main stages in the purification of water. So the first one is we need to filter. So filtration must be there. Filtration is just the process where you remove some insoluble substances from the water. Then the second one is chlorination, where you add chlorine. We move on to question 5. Under question 5, the table below shows the structure formula of various monomers and the polymers that can be made from them. So the first row indicates the monomers, then the second one we have the polymer. Okay, so let's have the first question. Identify the monomers which are hydrocarbons. So if you look at hydrocarbons, we want the monomers that contains of hydrogen and carbon atoms only. There never should be any other atom. So from this we can see that here there is hydrogen, 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 carbon, carbon. So this is hydrocarbon. Then for this one, this is not a hydrocarbon because there is a presence of fluorine. So this one no, but for W is also a hydrocarbon. So we'll say ethene and we'll say W. Then name the monomer W. So how can we name this monomer W? So the first one, we need to look at the prefix. The prefix is just the number of carbons. So the first one, we know we start with meth, where we are given 1, then eth, 2, prop, 3, but, 4. Let's just maybe end at pent, where we are given 5. So for you to identify or to name a given organic compound, first you need to make sure that the prefix you have mastered the prefixes, because you are going to need this in your examinations. So if you look at this W, we have 1, 2, 3. So the prefix is prop, because prop means 3 carbons. Now there is this double bond here. So the double bond is the suffix. Now the suffix, whenever you have a double bond, is ene. So this ene indicates that you are dealing with an alkene. So that's a concept here. So we add ene. So this becomes the propene. So that is how you name the monomer. Then we move on to draw the displayed structure for polymer W. So for polymer W, let's say we are using two monomers, propene plus another propene. Let me see if I can summarize this. So I'm going to use this space here. So the concept is we have one monomer plus another one. Let's just use two monomers. Then the product is a polymer. In our case, the monomer is propene plus another propene. Make sure the monomers are the same. Then the polymer, the naming of the polymer is, you always begin with the word poly, then you add the name of the monomer. So this becomes polypropene. From there, we need to look at the chemical formula. So the chemical formula will have C3, 3 carbons. Then how many atoms of hydrogen do we have? So we have 1, 2, 3 plus these 3, 6. So we just say C3H6 plus another C3H6. Then the formula for a polymer, for this addition, you just have to add the carbon. So there are 6 carbons, carbon atoms. Then the hydrogen will have 12. Now for a structure, we'll look at the way it is given. So it is like this. So we'll put these in brackets. Then here we can put N, but since we are given, we are using two monomers, we put 2. So the N represents the number of monomers that you are going to use. So in our case, we are using 2. So we need to write this, since we are using 2. Now make sure that the polymer produced under addition must have single bonds. We don't need the double bond now. So we'll follow the pattern of the monomer that we have used, so which is CH3, then hydrogen, hydrogen, hydrogen. Also here CH3, hydrogen, hydrogen, hydrogen. Then here you just have to leave. So this is the polymer that we can have, given that we have used two monomers. Now to summarize our work, we just say, we just use this. This is our polymer. Then we can enclose it in brackets. Then we put N here. Okay, so we move on to question D1. Identify the common feature among the monomers in the table above. So let's go back here. We see what we have in common. Okay, so the common feature is look at the first one. Ethene has a double bond. Tetrafluorine has a double bond. Then W has also a double bond. So that is the common feature that we can see. So say they all contains double bond. Between two carbon atoms. Then give the name of the compounds with this feature. We can just say alkenes. Whenever you have the double bond, you are dealing with the alkenes. Then decane, C10H22 can be cracked to produce hexane, C6H14, and butene, C4H8. explain the meaning of the word cracking. So breaking of heavy hydrocarbons to form simple or smaller molecules. Go to question 6. So 6a, give 2 ways by which rusting of iron can be prevented. So the first one we can say by painting. Then number 2 we can use galvanizing. We have also sacrificial protection, we have oiling, we have greasing, so we can use all those. Then question B, burning and rusting are two chemical processes. Give Roman number one similarity. So they both require oxygen. So for burning to occur, we need oxygen. Then for rusting to occur, we also need oxygen. Then one difference is that the rusting occurs in the presence of moisture, which is water, while burning does not occur in the presence of moisture. So just say one occurs in the presence of water. Okay, so we move on to C1. Name two non-metallic oxide which causes atmospheric oxygen. So non-metallic oxides, these can be basic, not basic, these can be acidic oxide or sometimes even neutral oxide. Then so the first that we can use carbon dioxide. It causes atmospheric pollution. Then state two sources of these pollutants. So the carbon dioxide can be produced by complete combustion of fossil fuels. Then in the second one, we can give sulfur dioxide. Sulfur dioxide can also be produced by complete combustion, or we can just say extraction of metals. For example, extraction of zinc produces sulfur dioxide. Extraction of copper also produces sulfur dioxide. So this is how we can answer these questions. Okay, we move on to question 7. Zinc can be reacted with steam using the apparatus shown below. In the reaction of zinc with steam, gas A and solid B are formed. Okay, we have rock seal who soaked in water, then we have heat there, zinc, water, then gas A. The first one, name gas A. So let's look at zinc. Zinc is a metal, react with steam. So the question is, what two products can be produced whenever a metal reacts with steam? So the first one that you're supposed to have is, we are going to have metal oxide. Metal oxide is a metal that contains oxygen plus the hydrogen. Always the gas produced must be hydrogen. So gas A is hydrogen. Okay, we move on to question B. State the product formed when gas A burns in air. What is gas A? Is oxygen. So whenever hydrogen burns in air, it will produce water. So remember, whenever we have a complete combustion, we are going to have a oxide. Water is chemically known as hydrogen oxide. This is the chemical name for water. So that is what will be produced if this gas A burns in air. Then question C, give two uses of gas A, which is hydrogen. The first one, to make ammonia in the Haber process. Remember, the formation of ammonia needs two reactants, nitrogen and hydrogen, giving us NH3. Then the second one, we say to make margarine. To make margarine. So whenever we are looking at formation of margarine, we are looking at hydrogenation, which is, if you look at the organic chemistry, organic chemistry tells us that hydrogenation is just the addition of hydrogen to an alkene in order to form an alkane, and that one is used to make margarine. So in hardening of the margarine. Then D1, what is solid B? So solid B is zinc oxide. Then for question 2, construct a balanced chemical equation with state symbols for the reaction between substance B and dilute hydrochloric acid. So let's first begin by a word equation. We know that we are dealing with a metal oxide. So what happens whenever a metal oxide react with any acid? So let's just say any acid. So the product should be salt plus water. So where is the salt coming from? From the metal oxide we get a metal, then from the acid we get the non-metal, which is the, in our case, chloride ion. Then the oxide from the metal oxide and the hydrogen from the acid will react to form water. So for example, we are dealing with zinc oxide plus hydrochloric acid. So how do you name the salt produced? So the salt, first you begin by naming the metal. Then whenever you use hydrochloric acid, you get chloride. So this becomes zinc chloride. I don't even know why I've mentioned this. Then plus water. So zinc has a valence of 2 and oxygen has a valence of 2. So this one will be a 1-to-1. Then hydrochloric acid has HCl in aqueous. Then we are going to have zinc chloride aqueous. Now zinc must have chlorine must have a 2, because zinc has a valence of 2, chlorine has a valence of 1. So if we interchange, will give us this, then plus H2O. So we just have to put a 2 in front of HCl. Then our equation is now balanced, because we have 2 hydrogen, 2 hydrogen, 2 hydrogen. Then 2 chlorine atoms, 2 chlorine atoms. So our equation is now balanced. So we will end at this question. So that's it for this video. Thanks for watching.